Hello and welcome to our second video in the series of organic chemistry. Today we will be talking about alkanes. That means we will talk about what alkanes are. We will introduce a few alkanes and in the end talk about molecular and general formula. An alkane can be defined as a saturated hydrocarbons. And I want to explain both terms to you, saturated and hydrocarbon. Saturated means that a molecule only contains single bonds. Let's quickly revise what a single bond is. I want to draw you the displayed formula of a carbon atom. So we see the four outer shell electrons of carbon. And the displayed formula of a hydrogen atom looks like this. And now both atoms can sort of agree in sharing their electrons. And then a chemical bond is formed, represented as a dash, and it means that two electrons are found in between these two atoms. And that's what we call a single bond. So there's one bond, two electrons in between two atoms. In this case, the carbon atom and the hydrogen atom. Of course, this can happen multiple times. So in order to construct a molecule, we can give it, for example, 3 CH bonds here. But a carbon atom, of course, is also free to form a single bond to another carbon atom. And then we have a carbon-carbon single bond. And in this way, we can create a molecule. And this molecule that you can see over here is saturated because it only contains single bonds. Now, if there's something like single bonds, then you rightly assume that there must be also something like multiple bonds. For example, double bonds. And I want to give you an example for this as well. We can start off again with the displayed formula of a carbon atom and bond it to two hydrogen atoms. And now in order to make a double bond, not only two electrons are shared in between two atoms, but 4 electrons are shared in between two atoms. So between the carbon atom now, we have 4 electrons that make 2 bonds. And that's what we call a double bond, or more specifically in this case, a CC double bond. I'll draw this molecule a bit more beautiful. So this is the same molecule, simply rotated and drawn a bit more neatly. Okay, what does hydrocarbon mean? Hydrocarbon means that a substance or molecule contains only carbon atoms and hydrogen atoms. We now want to have a look at two molecules, namely the molecule of methane and a molecule of a substance called ethene, and decide whether they are alkanes or not. And to do so, we have to check whether they are hydrocarbons. So the molecule of methane is a hydrocarbon because we can only see carbon and hydrogen atoms, and the same is true for ethene. Are both molecules saturated? The methane molecule is saturated because it only contains single bonds, but within ethene we see a carbon-carbon double bond over here, and that means that the molecule of ethene is not saturated, and for this reason methane can be called an alkane, but ethene cannot be called an alkane. I also want to introduce to you guys a very useful rule with which you can check whether a displayed formula that you may be asked to be drawn is correct or not. And this is that carbon atoms in organic chemistry always make 4 bonds, hydrogen atoms always make 1 bond, and later on when we also introduce compounds with oxygen atoms will make 2 bonds. Let's illustrate this with the molecules methane and ethene. So this carbon atom of methane has 4 bonds, 2 hydrogen atoms every time. But even the carbon atoms within ethene that are involved in a double bond, they still make 4 bonds. So they make 2 bonds, 2 hydrogen atoms, but they also make 2 bonds to the other carbon atom. So in total, we also have 4 bonds of the carbon atoms within ethene. And yeah, as mentioned earlier, hydrogen always makes 1 bond. I think that can be clearly seen. And oxygen atoms make 2 bonds. Now I want to introduce to you guys a few more alkanes. Let's talk first of all about what alkanes actually are. Alkanes can be referred to as a family of similar compounds. And the molecules of alkanes, they always differ by a CH2 unit. What do I mean by this? Let's have a look at the displayed formula of methane. And what we can do now in theory, so in reality it's much harder to do so, but on the paper it's quite easy. We can split the bond or break the bond here, and then we end up having this structure, a free electron at the carbon atom, and then the hydrogen atom over here. And now we can insert into this place a CH2 unit. A CH2 unit looks like this. We have a carbon atom bonded to 2 hydrogen atoms, and then we still have 2 unpaired electrons of carbon. And then this carbon atom in the middle can bond to the carbon atom on the left and the hydrogen atom on the right. And then we have produced this molecule. This molecule is apparently different to the molecule of methane. It looks different. That's why it gets another name. It's called ethane. But still, this molecule fulfills the criteria of being an alkane because it is a hydrocarbon. We have only carbon and hydrogen atoms. And it is saturated because only single bonds occur in the molecule. And in this way, we can produce many molecules that belong to the family of alkanes by always adding a CH2 group to the molecule. If we add another CH2 group to ethane, then we end up having a molecule of so-called propane. And if we do this another time, we have created the molecule butane. Yeah, you can already see that the name of organic molecules, so also the names of alkane molecules, follow a system, or they have a specific rule. So let's talk about the naming of alkanes. The name of an alkane and of any other organic molecule is composed of a suffix and a prefix always. And the suffix tells you which family a molecule belongs to. So the name methane has the suffix ane, and this tells you that methane belongs to the family of alkanes. And the prefix of a molecule name tells you how many carbon atoms are involved in the chain of this molecule. So if we look at butane, we can see at the table that the prefix but refers to 4 carbon atoms, and then the name butane tells you that we have a chain of 4 carbon atoms within butane, and the suffix ane tells you that the molecule is an alkane. In the end, we want to talk about molecular and general formulae. In organic chemistry, the molecular formula is noted down according to a system introduced by a scientist called Hill. And Hill decided that in organic chemistry, a molecular formula should always be stated by first mentioning the carbon atoms. So if we look at this molecule as an example, we find 2 carbon atoms, so we write C2. And in the second place, we always note down the hydrogen atoms. So we have 1, 2, 3, 4, 5, 6 hydrogen atoms, C2H6. And this is because carbon and hydrogen atoms exist in basically every organic molecule. And then all the other atoms that could show up in a molecule are added in alphabetical order. So in our case, we only have an oxygen atom here. That means we put the O at the end. And the molecular formula of this displayed formula, would be C2H6O. At the table at the bottom, you can see the molecular formula of the alkanes that we have been looking at before. So for methane, the molecular formula is CH2, for ethane it's C2H6, and so on and so on. You can check it by going back to the slide before. And when we look at the molecular formula, we can see a system. And this system allows us to calculate the molecular formula of any alkane that we want. We can sort of extract a general formula of alkanes, and this is CnH2n plus 2. So for example, and n is a variable, if we want to know the molecular formula of the alkane having 4 carbon atoms in a row, then we put n equals 4, and the molecular formula can be calculated as C4H 2 times 4 plus 2, and that's the same like C4H 8 plus 2, that's H10. And you see that we have figured out the molecular formula of butane. So that's how you can use a general formula to calculate the molecular formula of any alkane you would like. That's quite helpful. That's all for this video. I hope that was helpful to you, and I'm looking forward to see you in the next video.